Welcome to this quick look into the meshing capabilities of the Simpleware ScanIP software. In this video, I'm going to show you some of the options we have available when preparing surface and volume meshes. Here you can see we have a pelvis and a section of the left femur segmented from image data. These are shown in the dataset browser under the masks heading. And you can also see we have a surface showing a very simple mock-up of an acetabular cup, and that's shown in red here. So we have a selection of different types of models that we can create. If we go to the Home tab, we can see them all listed here. So we can create a new surface model. This could be useful for 3D printing or maybe some FE or CAD or CFD work. We can create a new FE model, that's a volumetric mesh, a CFD model or a NURBS model. So NURBS are larger patches often used in CAD work. So in order to create one of these models, we can either click on one of these buttons or we can go to the dataset browser, select the models heading, right mouse click and choose the type of model that we want to create. Or you can simply select one or more of the different parts that you want to have in the model and then drag and drop them onto the heading, and we get this dialog box pop up and we can decide which kind of model we want to create. So we're going to start with a new surface model. Now, one thing that is very important to note is that when you're adding different objects into a model, the order of these objects is important. So in Simpleware ScanIP, we use a priority system. So the objects at the top of the list have priority over those lower down in the list. So in this case, we need to make sure that the acetabular cup is above the pelvis. And in this case, the pelvis is also above the femur. So where the two objects overlap, the implant will take priority over the pelvis and the pelvis will take priority over the left femur. So now what we'll notice is that this is a context sensitive tab here and it automatically opens when you create your model. So here we have the model setup and all of our options, and we'll work through these as we go through. So one of the first things that we can do is just check our segmentation quality. So if we just check this here, you can see that no segmentation problems have been found. If you do have some, you could go back into your segmented masks and maybe make some changes or see if the automatic tool can fix them for you straight away. So if we right mouse click, we'll get to the model configuration. Now, this is really where we can set up all parts of the model. So the first thing to do is to choose our export type. Now we have a whole different range of export types, from 3MF to SAT. STL is one of the most commonly used, and we have two different STL options which I'm going to look at today just very briefly. The first is STL for 3D printing. Now this is a very quick setup, so you just get a few options, some smart mask smoothing. Smart mask smoothing allows you to smooth multiple parts in one operation, and you've got a couple of options here. I would stick with the default options in the first instance and then change them if you need to. And just quick export options for the coordinate system and the export length. If we look at the surface settings, again, very simplistic for this particular type of STL. You can just apply some simple triangle smoothing or some decimation if you wish. You can also use part grouping if you need to group different objects when you're working with them outside Simpleware ScanIP. So once you're ready, you just click close and then you go to this tab at the top and just click full model. So here you can see we've meshed the model now. So if we move in very close, you can see that we've got a very fine mesh. If I use the edges, then you can see that we've got really good representation of the topology of the structure. So this is a very high density mesh, but what if we wanted to create something with less elements? Now we could use that simplistic decimate option, or if we go back into our model configuration and we change instead to STL for FE, CFD and CAD, we get more options for the surface optimization. So now we can go in and use this coarseness slider to decide if we want a very fine or a very coarse structure. So I'd always recommend having a go at the default, which is -25. But in this instance, we're going to go to -50 for both the pelvis and the left femur. Now for the surfaces you can use the slider again, but it's also useful to just check the smallest preserved feature size on the surface that you're looking to work with. So in this case I'm just going to reduce this down to 1 millimeter there. You can also choose to look at the advanced options. This is not something that I'd recommend initially. I'd just give it a go with the coarseness slider and then go from there. So if we close this and then we go back to our surface model tab and click full model. So here you can see the output of that mesh. Now you can see that we've got much less elements. Instead of 900,000 elements, we've got a total of just under 61,000 elements. You can see that we've sacrificed some of the accuracy in the topology, but not a lot, and we've got a much smaller model which will be much easier to work with. So this is always something that you need to weigh up on how much accuracy do you need and what are you going to do with the model going forward, what's appropriate. So there are lots of different options there that you can explore for surface models. Now we're just going to have a very quick look at the FE models. So we can change the surface type quite easily by just using this drop down and selecting FE. Now the export type, you've got lots of different export types here for our volume meshes. So some are built for specific programs like Abacus and ANSYS and COMSOL and Adena. But then we also have some more generic formats like Nastran, Patran and VTK, and you can choose the one that's most appropriate for you. A lot of the model configuration is very similar. So we have the smart mask smoothing options again and the export options for the coordinate system and the export length. But when it comes to the meshing, we've got lots of different options that you can use here. Now I would suggest that you stick with the FE-free meshing algorithm and use all tetrahedra. You do have the option to go for quadratic with straight or curved edges if that's interesting to you as well. We've again got the coarseness slider that we can use, so here we could set this to -30 for the pelvis and maybe -25 for the femur, and again we've got the same slider for the acetabular cup. This time I might go for 0.8 as my smallest feature size that I want to keep. Now again there are a lot more options that you can explore, lots of things on the additional mesh quality improvement, so targets and metrics that you can work with. So at the moment we're using Jacobian, in-out ratio and edge length ratio to kind of optimize the mesh after it's been initially generated. You can also see targets for minimum edge length, maximum edge length, change rates, intersection checks, all sorts of things here. Again, I would initially just look at the kind of simple view, try a few models using the defaults, and then if you need to, access those options. When it comes to materials, we've got a few options here as well. We can use a placeholder for the material, so when it's output into maybe a simulation package, you can then assign a material with its material properties. You can use homogeneous properties and just enter them directly, or you can use a grayscale based approach. So this is where you use a calibrated CT scan to understand the relationship between the material properties of the bone or whatever it is that you've scanned and the grayscale value that's in the image data. And as long as that's being calibrated, then you can bring those material properties through into your model. You can also set up contacts. So for example, we might have a contact between the pelvis and the left femur, and we can add a surface or a contact pair. And we could do the same for the acetabular cup as well. We can also add node sets, shells, mesh refinement regions. These are all added in the same way. So you just click add and manage regions. You just create a region of interest that you want to use. So here I'm just using a sphere, and I'm just going to place this in the position that I want it to be in. So I've selected this region around the acetabular cup that I'd like to use, and then I just select what size of mesh I would like to use here. So I'm going to use 0.8, and then we can select the parts that we'd like this to operate on. So in this case, I'm just going to choose the pelvis. Once we're happy with our selection, we just click done, and that will be added into your model configuration. You can also set up boundary layers or part grouping, as I spoke about before. So once you're ready, you just click close, all the settings are there, and then you can just click full model. So here we can see the mesh generated for the FE model. Now you can see we've got quite a coarse mesh for the pelvis and for the left femur. So the area where we asked for quite a fine mesh refinement, you can see there. If we just make the acetabular cup invisible, you can see that in a bit more detail. Now at the point where these two intersect, you'll also find that the acetabular cup also has a very fine mesh. That's because we have matching nodes at the interface between the two. So if we just zoom out, the other thing I wanted to show you was the grayscale material properties. So to view those, you go into View, Visibility Options. Make sure that the pelvis is active, because this is the one that I've set up the material properties on. And then we just select mass density. And here you can see a range of values for the mass density for the pelvis part. And you can see that these are assigned to each of the elements within this range. So in this case, I chose 10 steps, and you can see the mass density listed on the right hand side here. So the other thing that we had set up was contact surfaces between the parts. So here you can see the contact surfaces, just a small area between the left femur and the pelvis, and here you can see the acetabular cup has a much larger area, so those are the areas that are in contact. So those can be really helpful when you go into your simulation software. So we'll just turn those off there, and then we can go back and turn the visibility options off. So from here, if we go back to the FE model, we can check the mesh quality, and we can see that no errors have been found and just a few warnings here, and get some details about how you would inspect your mesh using our help and tutorial files. So at this point, you can just now select export in the format that you've chosen. If you did need to change format, you can go back into the model configuration, and in a lot of cases, you don't actually have to remesh. You can just export straight away. So now I just want to leave you with a few starting basic tips. The first thing is to make sure that you have a really good segmentation. Check for floating islands and small cavities between your parts or inside your parts if you want solid objects. The next thing is to start simple. Try using the default options and then decide whether you need to decimate or add some more refinement into your mesh. And also think about the end purpose. So these things can really help to reduce your element count while maintaining good accuracy within your model. I hope you found this video useful. If you have any questions, please contact Simpleware support, and thank you for watching.